Most AI workflows have a dirty little secret. They don't improve. You run them, you get output. Something's a bit off. You fix it manually. You run them again, rinse and repeat forever. You are not building anything. You are just operating a machine that needs constant attention. That's not a system, it's just babysitting. And the frustrating part is, it doesn't have to be this way. There's an architecture for specific pieces that turns a static AI workflow into something that actually learns from every run. Something that gets better over time without you pushing it forward every single time. Once you get how these 4 pieces fit together, you can build this in any business, any industry, any use case. Let me show you how it works. The first pillar is SKUs, and this is the foundation everything else sits on. Most people may have heard of this, but in case you don't know how to use it in a system, I'm gonna explain it again. A SKU in Claude is basically a process document. Specifically, it's a markdown file. And I know markdown file sounds technical and boring, but stick with me because the concept here is genuinely powerful. Think about how your best employee operates. They don't just know what to do, they know how to do it, step by step. They know the edge cases. They know when to pause and double-check something. They've internalized your company's way of doing things. A Claude Code SKU is that, but written down in a way the AI can actually read and follow. Not just write a marketing email, more like Step 1, check the target audience in the brief. Step 2, look at the examples folder for our brand voice. Step 3, write 3 subject line options before writing the body. Step 4, if the email is for a product launch, always include social proof in paragraph 2. That level of specificity, that's a SKU. Here's the thing most people don't realize. When you just type a prompt to Claude, you are starting from scratch every time. Claude has no context about your business, your preferences, your past mistakes. You are basically onboarding a new employee every single morning. SKUs flip this completely. The SKU file is the onboarding document. Claude reads it before doing anything. So instead of you explaining what you want every time, you write it once clearly, completely, and then the AI just follows it. And because it's a file, you can update it, improve it, add decision logic. If the client is in the healthcare space, always flag for compliance review before sending. That kind of thing goes in the SKU. And now Claude handles it automatically every time. Honestly, the best way to write a SKU is to think about the last time something went wrong. What did Claude miss? What did you have to correct? Add it to the SKU. Don't do X. When Y happens, do Z instead. The more real-world experience you bake into the SKU, the better it performs, which leads up perfectly into pillar 2. Okay, so this is the part that actually makes the whole thing click. If SKUs are the foundation, the learnings loop is the engine. Here's the idea. You have a file called learnings.md. Every time a SKU runs, every time Claude completes a task, observations about what happened get written to this file. What worked well? What needed to be fixed? What edge case showed up that wasn't in the original SKU? Then the next time the SKU runs, the very first thing Claude does is read learnings.md. It sees the notes, it adjusts, it applies what was learned before. Over time, your SKUs get smarter and smarter based on real runs in your actual business. It's not hypothetical improvement, it's improvement based on what actually happened. There's a spectrum here. And where you land depends on how automated you want things. Option 1, manual. After a SKU runs, you write the notes yourself. This email was too formal for our audience. Next time, aim for a 7th grade reading level. You paste that into learnings.md. Simple, low-tech, and honestly a great starting point because it forces you to actually reflect on what happened. Option 2, semi-automated. You build a wrap-up SKU. We will talk about this in a second. And it does the reflection for you. After the main task is done, Claude writes a short summary of what happened and appends it to learnings.md. You might still review it, but you are not writing it from scratch. Option 3, fully automated. This is where it goes really interesting. You create a file called eval.json, basically a set of test cases. Each test case defines what a good output looks like and gives it a score. After every SKU run, Claude evaluates its own output against those test cases. If something scores below the threshold, it automatically writes a note to learnings.md about what went wrong and what to try differently next time. No human required, the system improves itself. Let me give you a concrete example. Say you are using a SKU to generate weekly performance reports for your team. The first few rounds are decent but a bit generic. You add a note to learnings.md. Always include a one-sentence headline that summarizes the biggest win and the biggest risk. Manager's skin and need this immediately. Next round, Claude reads that. It adds the headline. You notice the headline language is a bit corporate and stiff. You add another note. Next round is more direct. 6 months later, the SKU is producing reports that your team actually reads and acts on. And you didn't have to re-prompt or re-explain anything. The line is just stacked. That's compounding in action. Every round builds on the last. Pillar 3 is hooks, and this is how you automate the when, not just the what. So you've got your skills, you've got your learning loop, but someone still has to trigger everything right. Someone has to say, okay, run the skill now. Hooks remove that person from the equation, or at least reduce how often they need to show up. A hook is a trigger. Something happens, and a hook automatically fires some action in response. The classic example in a coding context. Every time Claude makes a change to a code file, a hook automatically runs your test suite. You don't have to remember to run tests. You don't have to tell Claude to run tests. It just happens the hook sees code changed and responds run tests. Or before a commit goes through, a hook runs a linter. Clean code only every time without anyone having to nag anyone. But here's the thing, this isn't just for software teams. The hook pattern applies to any workflow where event X should always trigger action Y. Think about it in a business context. A new file lands in a folder. Trigger a skill that processes and categorizes it. A skill completes. Trigger the wrap-up skill to update learnings. A calendar event ends. Trigger a skill that drafts the follow-up email. The pattern is the same. You are wiring up automatic responses to events, so the system keeps improving without you pushing it every step of the way. There's a related concept worth mentioning here. Background tasks. Some things need to stay running continuously. Let's say you run an e-commerce store, and you've built a Claude Code skill that monitors your inbox for customer refund requests and drafts responses. For the skill to work, something needs to be constantly watching your inbox. The moment you close Claude Code or start a different task, the watchers die. You miss emails, the system breaks. A background task fixes this. You set it up once, keep watching the inbox, always. Now that watcher just runs quietly in the background 24/7. Claude Code can be doing something completely different. Generating your weekly sales report, updating product descriptions, whatever. And the inbox watcher is still alive, still watching. The moment a refund email lands, it gets picked up, the skill fires, the draft gets written, nobody has to babysit it. Here are some other real business examples of what you run as a background task. Watching a folder. Clients drop files into a shared Google Drive folder. The background task notices immediately and triggers your processing skill. Monitoring a form. Someone submits your contact form. The background task catches it and kicks off your lead qualification workflow. Keeping a dashboard live. You've got a reporting dashboard that refreshes with new data. The background task keeps the data feed running, so it's always current when you open it. Syncing between tools. Something quietly watching for changes in one system, for example your CRM, and pushing updates to another like your project management tool. The pattern is always the same. Something needs to be always listening, so the rest of your automation can react in real time. Rather than you manually triggering things or running them on a schedule or hoping the timing works out. Here's the shift in thinking that hooks require. Instead of thinking what do I need to do next, you start thinking to what should always happen when this happens. You are designing the rules of the system, not running the system manually step by step. That's a fundamentally different relationship with AI tooling, and it's a much more scalable one. The fourth pillar is the one that ties everything together, the wrap-up skill. Let me paint you a picture of what happens without a wrap-up skill. A task runs. It goes pretty well, mostly. A couple of things could have been better. You make a mental note, you move on. 2 weeks later, you are running the same skill and you make the same small mistake because you never actually wrote a mental note into learnings.md. The loop didn't close, the system didn't improve. This is shockingly common, not because people are lazy. It's just that updating a notes file is friction, and friction kills habits. The wrap-up skill eliminates that friction entirely. Here's the basic structure. You've got your main skill. Let's say it's a skill for writing client proposals. That skill runs and produces the proposal. Then automatically, either via a hook or just as the last step in the workflow, the wrap-up skill kicks in. It looks at what just happened. What did the main skill do? What was the output? Were there any decision points where things could have gone differently? It writes a brief summary, something like, client was in the legal industry. Tone adjustment was needed. More formal than default. Output was accepted without revision. Note: legal clients consistently prefer formal register. Consider adding industry detection logic to the main skill. That note goes into learnings.md. Next time someone submits a brief for a legal client, the main skill reads their note and already knows to dial up the formality. The wrap-up skill itself is still a skill document, a markdown file. Just like everything else, it has its own steps. Something like, review what the main skill just did. Identify 1 to 3 things that worked well. Identify 1 to 3 things that could be improved or were unexpected. Write the observations to learnings.md in plain language. Optionally, flag anything that needs human review. You can get as detailed as you want this. Some things around very structured wrap-ups that follow a specific template. Others keep it loose and conversational. Either way, the point is the same. Capture what happened so the system can use it next time. I want to be direct about this. Most people who build AI workflows stop at the skill. They write a good process document, they get consistent outputs, they are happy, and that is an improvement. But the wrap-up skill is what separates AI that does my tasks from AI that improves my task over time. It's the difference between a tool and a system. And once you have it running, you start to notice something kind of remarkable. You look back at your learnings.md after 3 months, and it reads like a compressed version of everything your business has learned about how to do this work well. It's institutional knowledge, captured automatically in a file you can search and share and build on. Let's do a quick pass through the whole thing. Skills are your process documents. They tell Claude exactly how to do a specific task in your business, not just the what, the how, the when, the edge cases. The learnings loop is what makes skills smarter over time. After every run, observations go into learnings.md. Before every run, the skill reads it. The loop compounds. Hooks automate enforcement. They make sure things happen when they should happen. Tests run after code changes. Wrap-ups run after tasks complete. Files get processed when they arrive. You're designing rules, not pushing buttons. The wrap-up skill closes the loop automatically. Instead of relying on you to remember to update learnings.md, the system does it itself. Improvement becomes continuous, not dependent on your attention. If you are sitting there thinking, okay, this sounds great, but I don't know where to start with one skill, just one. Pick the task you do most repeatedly and write down. In plain language, exactly how you want it done, every step, every decision point. Save it as a markdown file. Run it a few times, notice what's missing, add it. Then add a learnings.md and start jotting notes after each run. You don't need all 4 pillars on day 1. The point is to get something in place and let it grow. The system improves itself, that's the whole point, but it needs somewhere to start from. Here's what I want to leave you with. Every business has knowledge, hard-won knowledge about how to serve customers, how to communicate, how to solve problems. Normally, their knowledge lives in people's heads, and it walks out the door when they leave. And it's never quite the same when you try to recreate it. The self-improving AI system I've described today is a way to capture that knowledge in real time from real work and to make it available to every future run of every skill. It's not just automation. It's a living knowledge base that gets better as your business operates. That's what's building, and Claude Code gives you the pieces to do it. Alright, if you want me to go deeper on any of these 4 pillars, the actual file structures, how to write eval.json test cases, or how to design a wrap-up skill from scratch, let me know in the comments and I will make a follow-up.